Okay, we switch back to English to announce our next speaker. It gives me great pleasure to now introduce Gregg Christmann from Oracle. Gregg is the product manager for Oracle Advanced Compression, and compression is also the topic of his talk. Gregg will share insights and best practices and show us how to get the most out of Oracle compression. It's always exciting to get first-hand information from product managers, and I look forward to your talk, Gregg. The stage is yours.
Thank you. Good morning from I guess, California, and good evening to everybody. As you mentioned, my name is Gregg Christmann. I'm the product manager for advanced compression and hybrid Columnar compression. I've been the product manager for about 12 years. So I have hopefully some useful insights. And given our time constraints, let's go and start taking a look at those right away. So before we sort of jump into some of the best practices and insights and things like that, one thing I always like to do in my presentations is talk a little bit about the features. So we're not going to do a deep dive by any means about this, but one thing we learned over time is there's a lot of features and capabilities that are part of advanced compression that are often overlooked by our customers. And we really try to make sure you're aware of all the features and capabilities of the feature. So you know what to look for, you know what's there, you know what you take advantage of, things like that. So we're going to do a real kind of walkthrough very quickly about some of the major features, so you're just aware of all the different types of compression that are possible. And the big four, I call them, are advanced row compression, which is the data compression component of advanced compression. It's about a 50% reduction in storage footprint, works with both OLTP and data warehouse. Advanced index compression, which is probably one of the most overlooked features of advanced compression. I can't tell you the number of times that we'll talk to a customer and they'll be using the data compression, pardon me, but not the index compression. And it's really worth taking a look at if you're really looking to optimize your storage savings. I highly recommend looking at the advanced index compression. Again, about a 50% storage reduction, and works both with OLTP and data warehouses. RMAN backup compression that helps reduce the size of your backups, which usually translates to faster backups and faster recovery. And advanced lob compression, which can compress the lobs that are stored in secure files. So again, about a 50% reduction in the footprint there. So those are really the big four, but there's some other features. Whoops, wrong way. That you should be aware of as well. And these are included as part of advanced compression. There's advanced network compression, and we're not going to go into these. I'll point you to some documentation about these things. I'm sorry. Advanced or data guard redo transport compression compresses the redo between the primary and the standby. Data pump backup compression will actually compress the export files. And if you use FlashBack Data Archive, you can actually compress the archive files themselves, the history tables. So again, I don't want to spend much time on these, but I do want to make you aware of them. If you go to the data sheet, which is available on oracle.com, if you go to the advanced compression page on oracle.com, and you click on the data sheet will go through every feature of advanced compression. And again, I bring this up mostly because I can't tell you a number of times that we've gone someplace, customers are very happy with the data compression, but they've not looked at the lob compression or the index compression. And those are all features that are included as part of advanced compression. So you really want to take advantage of those if you're using advanced compression. So again, that's sort of the end of the review there, but I just want to make everybody aware of all the features and where you can get a list of all the features of advanced compression. So first thing I thought we'd start talking about a little bit about advanced compression specifically is what type of applications actually use advanced compression. And it's pretty broad range. The first, and sometimes a little bit of a surprise to people, is it will work with any commercial or packaged application. Pardon me. Includes things like eBusiness Suite, PeopleSoft, JD Edwards, Siebold, SAP, and others. So if you're using a commercial packaged app, it is very possible to use advanced compression with that. There are no sort of SQL changes required at all. You don't have to go through and change SQL. The only thing you really need is Oracle Database Enterprise Edition. There's no other requirements. There's no specific hardware requirements. As long as you have a system that's running Oracle Database Enterprise Edition, you can run advanced compression there. And essentially, it should work with any commercial packaged app. We actually get very good results SAP, as well as eBusiness Suite. Oracle runs their internal businesses on eBusiness Suite, and we actually use advanced compression as part of that. The next one is any size OLTP or data warehouse application. As I mentioned earlier, you can use advanced compression with OLTP or data warehouse applications. Most customers understand the fact that they
I actually cannot hear.
Even a small table, there are still benefits from compressing it. The storage savings is there. It's a lot less blocks we have to move around, and that translates less I/O and things like that, which translates directly to performance. Even with the smaller tables, although the storage savings may not be overwhelming because it's just a small table to begin with, but there are performance benefits there. The fact you cut down the number of blocks in half typically means we're moving a lot less number of blocks around. We're getting more data into the data buffers, and that translates typically to better performance for the application, particularly around queries. So there are benefits, we believe, to compressing even smaller sized applications, ones with smaller amounts of data. So again, so if you're looking for where can I use this at, any commercial packaged application, any size OLTP or data warehouse application. If you want to see usage examples, there's some here. A lot of these are available on oracle.com, and I'll point you to that app, to where that is at the end of this session here. A lot of customers ask, who uses this? It's pretty much about anybody you can think of, about every type of industry you can think of, any type of application you can think of. It's pretty much used around the world. It's a pretty heavily used feature, and it's used by about every industry you can imagine. So, move on to more interesting stuff. The biggest question we usually get is, or the most frequent question, should I say, is how do I enable compression for my existing tables without any downtime, or how can I do it online? And so this is for existing. If you have existing tables and you want to enable advanced compression, there's two ways to do it online. You can do alter table or an alter partition and move, and you can actually use the online keyword or online option there, which will enable online, or you can use online redefinition. Probably the most frequent one that I run into with our customers is they will use online redefinition to enable compression for an existing table online. So this will give them access to the table while they're enabling it for compression, essentially rebuilding it. And then the old table will be dropped, and the new table will become the active table, and then they'll have compression enabled from that point on. And once you enable compression, once you rebuild that table, compression sort of enabled, there's nothing else you have to do in order to maintain it. It will self-maintain going forward, but you do have to rebuild your existing tables to enable compression. And these are, like I said, the two most common methodologies doing it. And online redef is probably the most common of all the ones that I've seen being used. If you're looking to do this, I refer you to the documentation for more detail. I did want to point out the two methodologies that the customers use currently. The other question that comes up frequently is, when should I use advanced compression versus hybrid Columnar compression? So hybrid Columnar compression is a type of compression, a little bit different in the way it actually stores the data, that is included with Oracle Database Enterprise Edition, as long as you're on one of the platforms that supports it. So to use hybrid Columnar compression, you have to use Enterprise Edition, and you have to be on a platform that supports it, which is typically Exadata, Supercluster, Pillar Axiom, ZFS Storage, FS1, or Oracle Database Appliance ODA. So if you're using Enterprise Edition and you're on one of those platforms, then you have hybrid Columnar compression available to you without any additional licensing required. But the question does come up, assuming you're on one of those platforms, pardon me again, which compression should I use? And it comes down, it's actually a fairly simple delineation. Advanced row compression, which is part of advanced compression, it's the data compression component, is designed for both OLTP and data warehouse applications. So you can use advanced compression, advanced row compression on essentially any type of application. OLTP, data warehouse, doesn't matter. It typically gets a 2 to 4x compression ratio. A 2x compression ratio is about a 50% reduction in the footprint. So if you have an application specific, again, data warehouse is fine. But if you have an application that is specifically making modifications to the data using DML inserts and updates, you want to use advanced row compression for that application. Advanced row compression is built for LTP and data warehouse. It's designed for data that's being changed over time, doing DML updates and inserts, and it will maintain that compression over time. So OLTP application, you definitely want to use advanced row compression. If you're on a system that supports Hybrid Columnar, you can use Hybrid Columnar, but you primarily want to use Hybrid Columnar for applications that are read-only or read mostly. You typically pardon me, don't want to use Hybrid Columnar on applications that would be OLTP by nature. You want to use Hybrid Columnar on applications that are read-only, read mostly, which would be typically a data warehouse application. You don't want to be using Hybrid Columnar where you expect a lot of DML changes to occur. If you're doing a lot of inserts and updates, that's not the ideal candidate for Hybrid Columnar. Hybrid Columnar, when you actually do DML updates or DML inserts, does those and it puts them into a lower compressed state than it would be typically. So Hybrid Columnar gets somewhere between 6 to 15x compression ratio typically. If you do a DML insert, do a DML update, the compression ratio for what was inserted or updated will be down somewhere around 2 to 4x, more like advanced row compression. And you'd have to rebuild the table to get it back to a Hybrid Columnar fully compressed state. So you really want to use it for query only, query mostly. If you're making a few changes, that's fine, but you want to be query only, query mostly. And there's two levels of Hybrid Columnar. There's the query or warehouse level, which is actually used for data that's being used for reporting purposes. And there's Hybrid Columnar archive level, which is used for colder data, historic data which isn't changing very frequently. And you can pick and choose which one you want to use there. And as I mentioned earlier, the compression ratio will change between will be between 6 and 15x, depending on which level of Hybrid Columnar you choose. But again, really simple way to think about this: OLTP has to be advanced row compression. If you on data warehouse and you don't have Xdata or one of those other storage platforms, you can still use advanced row compression. If you're using if you're a data warehouse on one of those platforms that supports Hybrid Columnar, you can use Hybrid Columnar, but only for query only, query mostly data. Here's a nice little simple chart. I actually pulled this out of the documentation. I actually found it very useful. It goes through and talks about the different types of compression, the CPU overhead, and what type of application it's designed for. So it's a kind of useful thing to have. I also want to talk a little bit before we get sort of best practices about index compression. There are two types of index compression that are available to you. If you're using advanced compression, we have included as part of advanced compression something called advanced index compression. Also, we have a free version of index compression. It's called prefix key compression. If you're using Enterprise Edition, the free version of key compression is available to you. There are some similarities and some differences between the two, and when you choose to use the one over the other. If you don't have advanced compression, you would obviously choose the free version of it, the prefix key compression. You can actually compress the indexes and not compress the data. You can compress data and not compress the indexes, or you can compress both. It really doesn't matter. You can sort of pick and choose which one you want. At one level, basically advanced index compression and prefix, the free version, the prefix key compression, actually have a level of compression that's very similar to each other. In terms of advanced index compression, it's called advanced index compression low, which equates pretty much to a prefix compression. So it does the same type of thing the free version does. The only difference at that level between the free version and the index low compression of advanced index compression is that the prefix compression requires the DBA run something called analyze index to figure out the best way to do the index compression. With advanced index compression, you don't have to run analyze index. The database will figure out for you the best way to do the compression. It doesn't require any sort of input from the DBA. So that's really the biggest difference. If you really look at the low level of index compression, and you look at the prefix key compression, they're very similar in what they do. They'll get the same compression ratios. The biggest difference is that the prefix key compression requires a little more interaction with the DBA to sort of set it up and get it going. Now, at the high level of index compression, for advanced index compression, again, a higher compression ratio, sometimes mostly in the 4 to 5x range, sometimes much higher. It does a lot more aggressive compression. It can get actually a very good compression ratio because it actually looks at each block independently and figures the best way to compress that block. So if you're looking for the highest level of index compression, the advanced index compression high is a great way of going. If you're looking just at some great index compression, you can't choose between the advanced index compression or prefix key. If you don't have advanced compression, use the prefix key compression. If you do have advanced compression, use the advanced index compression below. They'll both get similar ratios, compression ratios, but the database does more of the work for you with advanced index compression versus the free version of the index key compression. Now, hopefully some useful insights or best practices around those. So, a couple things to keep in mind. If you're enabling advanced row compression, so you have advanced row compression enabled, and you expect a lot of updates, one of the things to check is your %free setting. Now, if you think about it, %free is where we go to get space if we need space for updates. So if you start running on that space, you may see row chaining and row movement going on, and we want to try to avoid that. One thing I've noticed, not very frequently, but sometimes with customers who enable compression, is that they don't look at their %free when they expect, or they don't sort of review that in lieu of looking at how much update work they expect to do. So what I mean by that is that if you expect to make a lot of updates to a table, this could be either with or without compression, it doesn't matter. But if you expect to make updates, check %free, make sure it's set appropriately to make sure there's space reserved there for the updates. The only time I've ever seen, usually with advanced compression, the query performance improves, and as well as the inserts and updates will perform about the same as they were before compression. So once you enable advanced compression, you should see your query performance go up. In terms of inserts and updates, you should see the performance be about the same. You might see some that are slower, you might see some that are faster, but overall, you'll see typically the same type of update performance as you did before compression. The only time I've ever seen, and this has been relatively few, but the only time I've ever seen sort of impact on performance that it was unexpected was customers who were doing a lot of updates, but had not adjusted the %free to sort of accommodate that. So %free defaults to 10. They start doing a lot of updates, and then they start seeing some row chaining and row movement going on, and that causes some performance to slow down. So one thing, again, keep in mind, if you're enabling compression, and this doesn't matter, and this also applies to tables that aren't compressed, but if you're enabling compression, looking at %free, if you expect a lot of updates to happen, make sure your %free is sort of adjusted to make sure it has space to accommodate that. And if you do have, if you are doing some updates, you think, boy, this is a little bit slower than I would have thought it should have been, go look at %free and see if it's still small. It could be you are seeing some row chaining going on. And on the same vein of that, or sort of thinking down the same route there, chain row compression, we actually changed the database in 12CR2 and sorry, I got distracted. We actually made a change. So in Oracle release 12C release 2, we actually made it so the chain rows are compressed. Before that release, we did not compress chain rows, but after 12CR2, and including 12CR2, we do compress the chain rows. So you will, even if you do get row chaining in 12CR2 and above, you will see the compression maintained, but if it's before that version, then we don't maintain the compression for the chain rows. But anyway, just keep in mind your %free. You can do in-place row level compression. You can compress data in place instead of rebuilding the table. There's something called automatic data optimization, or ADO. I'll point you to the white paper about that. ADO has the ability to compress a table in place without requiring the table get rebuilt, and that's new in 12C. It was introduced in 12C, so that isn't available to you if you want to do it to enable compression without having to rebuild the table. And I'll point you to a white paper about that at the end. Unfortunately, we just don't have the time to sort of dig a little deeper into that, but I will point you to We improved our array insert compression optimization. Before 12CR2, you do array inserts. They could be a little bit slower. They're getting recompressed a lot. We actually optimize those in 12CR2 and above to make sure they perform better. The two here on the right side here, I really want to spend a little time on. If you use transparent data encryption, if you're thinking about using transparent data encryption, it works very well with our compression. The two work very, very well together. The thing you want to remember is if you're using transparent data encryption, Oracle's transparent data encryption, you want to use table space level encryption. The reason you want to do that is that we will compress before we do the encryption, so you get the best possible compression while also getting the encryption. If you use column level encryption with compression, we actually compress after the encryption, so it will impact the compression ratio. You will typically get a lesser compression ratio. So you want to make sure that if you're using transparent data encryption, you use table space level encryption, because the compression will happen before the encryption. But the two of them do work very well together. We have a number of customers who use both. There are benefits around performance of using both, but also just keep in mind you want to use the table space level encryption. Some common questions. What is the overhead associated with advanced row compression? It's typically about 3 to 5% CPU is what's reported by our customers. And the CPU overhead is often offset by the reduced IO. So because we're reducing, when you compress, you reduce the number of blocks. That means a lot less number of blocks we have to move around. I mean, more blocks we get from data buffers. The blocks are more tightly packed. Tables may become memory resident now, those type of things. But it does overall, in terms of this, the overhead, it's about 3 to 5% CPU. Do I have to compress all the tables, partitions of my database? No, you can pick and choose what you want to compress. As I mentioned earlier, some customers will choose only to compress the largest tables. So they'll draw a line somewhere. They'll say anything that's smaller than this, I'm not going to compress. And that's perfectly fine. You can pick and choose which tables you want to compress. You don't have to compress all at one time. You can compress over time. Some customers will start with the largest tables first, and over the course of months, they'll then compress the rest of the smaller tables as well. It's totally up to you. There are performance benefits in terms of reducing the number of blocks through compression. Just keep that in mind, but you can still pick and choose which tables and partitions you want to compress. When we deployed advanced compression internally at Oracle, we actually initially only compressed the largest tables, and then over time we've gone on to compress the other ones, but initially it was just the largest ones. Is there any other admin work needed to maintain compression? Nope. Once you enable compression, it runs by itself. There's nothing you have to do. There's nothing that you have to maintain. The system will self-maintain itself. What are the different levels of compression? You can choose either compress at the partition level, the table level, or the table space. If you choose the table space, it becomes the default for that table space. So if you say compress default at the table space level, it'll automatically compress tables for you when they are built or they are rebuilt. What can I do to improve my compression ratio? There's two ways to do it. I've seen customers talk about. First is you can sort the data. Because we use a deduping type algorithm, we're looking for duplicates on the block. The more duplicate values that exist in the block, the greater the compression. The more you can do to get more duplicate values in the block, the greater the compression will be. So some customers will sort the data before they load it. I've seen that have an impact on compression in a positive way. Other customers have played around with changing the block size. Again, the more duplicate data exists in the block, the greater compression. A larger block size should have a greater compression ratio. If you get more duplicates together in the block, again, something to play around with. I would test that before you deploy any of those. You want to make sure the benefit you're seeing outweighs the cost of time or effort, whatever it takes to do the sort or to change the block size, etc. Will compression help my RMAN backups? Yes, it will. Whatever you compress, if you compress data, you compress indexes, you compress lobs, they will stay compressed during RMAN backups, which means a smaller footprint for your RMAN backup. So your RMAN backup should be faster, the recovery should be faster. You don't have to uncompress during recovery. We keep everything in its state it is when we did the backup. So the data indexes will stay compressed during the RMAN backups. We actually also keep everything compressed in memory, so we don't have uncompressed in memory. So that's a lot, also where some of the performance benefits come from as well. But RMAN can be a significant win in terms of reducing the size of the backups due to compression. What to watch for? As I mentioned earlier, row chaining, I can't mention that enough. Again, I don't run into this very frequently, but I do really make a point of make sure that you think ahead of time. If you do expect updates to a table, to check the percent free to make sure it's not greater than the default. Again, if a customer comes to me and says, my updates are running slow and I don't know why, 9 6 out of 10, the percent free is still the default, and they're doing a lot of updates that they've simply exhausted the free space in the block, and they're seeing row chain going on. So again, something to keep watch for. If you're doing bulk loads, if you're doing any type of bulk inserts, the best way of doing it is through conventional path. It is the fastest, sort of best optimized way to do a bulk load. So if you're trying to get a lot of data in the table, and the table's compressed, doing it as a direct path operation, which is insert append, it's SQL loader, create table select, those type of things. Anything that's a direct path is the fastest, most optimal way to do the bulk load. The data is placed into a block, it's compressed, and written out. It's very quick. Compare this to things like a conventional path bulk load, where you're doing more of a DML, large DML inserts. It may take multiple recompressions, a little bit more overhead with those. So if you want the best performance possible, if you're loading a lot of data, anything that's direct path will give you the best possible performance in terms of compression, doing a bulk load. Also, if you're doing testing, if you're testing with advanced compression, use your own data, use your own applications, use your own systems. Don't create test data, don't create test applications. You want to see how it performs with your data and your applications, so test with those. If you do anything else, if you create test data, you'll know how it processes test data. If you build test applications, you'll know how it performs test applications. You really want to see how it performs with your own data and your own applications. Some other things to watch out for in our last few minutes here. Something called prefix index key compression bloat. Remember, as I mentioned earlier, there's a free version of index compression called prefix key compression. One thing you watch for that doesn't happen very frequently, I've only run into this a few times, but it is possible that you may turn that on and the index gets larger, which is what we really don't want happening. So it is possible that the amount of overhead it takes to manage the index compression is greater than the amount of compression you're getting. And with the free version of the key compression, it is possible you could see that. It's very unlikely. I've only run into it maybe 3 or 4 times in the last 10 years. But it's something to watch for. If you turn on the free version of the index key compression, you're using it to compress the index, and the index starts getting larger, it is very possible that the amount of compression we're getting doesn't outweigh the amount of overhead it takes to manage it. So you want to turn off the index key compression for that. One of the advantages of the advanced index compression is you won't see that with advanced index compression. Advanced index compression would figure that out ahead of time and wouldn't let that happen. But with the free version, it is possible that the index could grow in size. Very unlikely again, but it's something to watch for if somebody says, hey, my index is getting larger and I turn on compression. If you're running 11GR1, it's possible that you could have seen with 11GR1 the updates causing the table to grow in size. There was an issue with 11GR1 compression where indexes where the data would grow in size if you did a lot of updates. Again, that was fixed in 11GR1 and also ported to 11GR2 and beyond. So you won't see that any longer. But if you are an 11GR1 system, especially if it's unpatched, and you turn on advanced compression, and you saw your table start growing in size after updates, you could be running into this issue. You want to patch up your 11GR1s. But if you're on a patch system, you're on anything 11GR2 and above, you wouldn't see this. I just want to make you aware of that fact. And in terms of advanced lob compression, if your lob's already compressed, you may not see much more compression out of your lob compression. If whatever created those lobs already compressed it, it's unlikely that we'll get much more out of it. So again, just keep that in mind. With AWRs, there's a couple calculations you can do with AWRs to see whether you're using conventional path or bulk, conventional path or direct path loads. This is useful for if you're doing bulk loads, but you don't know what's going on underneath the covers, and you want to know whether you're doing conventional path load or bulk or direct path load. So there's some simple calculations you can kind of calculate these numbers based on these fields. And if it's one of these numbers is very high, the other one's very low, then you're probably doing that type of bulk load. Some simple ways to determine if you're using any of the advanced compression features, and also if you want to determine which tables are compressed. So I'm hoping these slides are available afterwards, but if not, I can definitely make them available to you, and we'll talk about that. There's a great white paper available on oracle.com. It talks about getting started with advanced compression. They'll talk about using Compression Advisor, which is a free tool that will go through and determine your compression ratios for you. It's free to use, does not require any licensing for advanced compression, just requires you to be on DBE. and I'll point you to oracle.com at the end. Also, if you're thinking about a proof of concept, if you want more details about what we talked about today, we only had a short amount of time. There's a proof of concepts document on oracle.com. It talks about best practices. I'll point you to that as well. It's a great way to get more information about what we talked about today, as well as get more information in general about using advanced compression. And I think we're on the last slide here. We just made it. Under join the conversation, if you go to the third bullet, that's the oracle.com page. It has all this information on it. There's white papers about advanced index compression. There's advanced compression, the proof of concept documents here, the customer success stories, as well as I mentioned earlier, the automatic data optimization. There's a white paper here about using ADO. So we're going to definitely want to suggest that. And oops, I think we are at the end here. Oh, some MOS notes. These are great MOS notes to help you use advanced compression. If you think about using advanced index compression, there's a white MOS note on here that help you determine how to use the index key compression, the free version of index compression. So definitely take a look at that. But in general, there's some good, just general usage of advanced compression MOS notes here. And I think we are done. So I think we're good. We made it just in time. I'll go back to this page. If you, again, I don't know if these slides are made available or not. If they're not made available, please just email me at greg.christmann@oracle.com and let me know you're at the session and you want the slides, and I'll be more than happy to send you the slides. Or if you have any questions, I realize we kind of had a short amount of time to rush through some of this, but if you have any questions about this, I'm definitely more than happy to take any questions. If you want to contact me or if you want to copy the slides, feel free to contact me. And I think we have time for questions, I believe, at this point.
Yes, thank you very much, Greg. Clemens, I guess we're going to make the slides available to the people, aren't we?
Yes, we do.
Oh, perfect. Okay.
Yeah.
Okay, good. Does anybody have a question for Greg? Okay. Greg, the question of Mario is when table compression is not a good idea.
When is table compression not a good idea? There's very few places where table compression is not a good idea. The first one is on a table which we call like a queue table or a message table. A queue table, in our definition, is something that is a table which you're loading, you're using very temporarily, and you're sort of deleting the contents and reloading, and it sort of goes through that cycle where you're creating a table, you're loading your data, you're deleting it, relatively quickly. You're reloading the data, deleting the data. That it goes through that type of thing where the data is not being kept very long. And the only reason we don't suggest compressing that is because you're burning some CPU to do the compression, but you're not really keeping the benefits around because it's just being deleted again. So if you have something that's like a queue table or a message table or something like that, where the contents are very rapidly changing over all the time, that's not a good place for compression. Other table, if you're using something prior to 12C, if you're on 11G, if you had more than 255 columns, you wouldn't want to use compression on a table that had more than 255 columns prior to 12C. So 11G, if you have a wide table of more than 255 columns, you wouldn't want to use compression there. Compression was designed for tables with less than 255 columns, 11G. In 12C and above, that restriction was removed, so it's no longer an issue. And you won't want to use compression on system tables. Remember, our compression is really designed for user tables, indexes, things like that. So you wouldn't want to use it there. Other than that, it's really designed for any sort of LTP data warehouse application.
Okay. And we have a question from Hannah. Do we need an advanced compression option for RMAN basic compression?
No. So if you have RMAN basic compression, it's my understanding that that is included with RMAN, so you don't need it for that. Where you would need advanced compression in terms of RMAN is there's 3 levels of RMAN compression included with advanced compression. There's low, medium, high. If you want to use those, that would require advanced compression option license. But other than that, the basic compression does not require advanced compression.
Okay, thank you. Any other questions? Okay, Mario, Is advanced index compression good for bitmap indexes?
Bitmap indexes are already compressed, so you wouldn't need it for a bitmap index.
Okay.
Already compressed. You don't need, and you don't need advanced compression license to compress your bitmaps.
Okay. Okay, so I think that's about it. So thank you very much for sharing your insights on compression, Greg. It was great having you here.
Well, thank you. I appreciate the opportunity.
Yeah.
I'm speaking. Hopefully, one of these days we'll be back doing this in person again.
Okay. Yeah. Sure. Okay. Thank you very much, and have a good day.
You too. Thank you. Thank you, everybody.
Thank you. Bye.